The year is 1942. In the midst of World War II, a group of scientists were tasked with a secret mission which would change the course of history. Led by American physicist Robert Oppenheimer, the Manhattan Project was started. What followed was a multi-billion-dollar program which saw great scientific minds working together to produce the world's first atom bomb. To start, nuclear fission was the key to making the atomic bomb. It was discovered in late 1938 by German chemist Otto Hahn. The process of fission occurs when a neutron is slammed into a larger atom at a high speed, which will then make it split into two smaller atoms. During this process, additional atoms are also released, and then we see a chain reaction occur, where this just keeps happening. And while this is happening, a huge amount of energy is released. And the way this made it to America, this technology, this news, was from Niels Bohr, because he talked to Otto Hahn before he went on that trip to America, and then he kind of told American scientists about it. And then we saw research at Columbia University after in the US. And then about a year later, after some research, we saw Albert Einstein and Leo Szilard draft a letter to the President of the United States, FDR. In August 1939, we kind of see the start of the Manhattan Project, where Leo Szilard and Albert Einstein draft a letter to President Roosevelt. This letter contained information about how nuclear fission with uranium could create extremely powerful bombs. There was concern that the Nazis would be working on the atomic bomb, so the two physicists urged FDR to begin research on uranium and fission. In October, FDR would receive Einstein's letter and soon found the Uranium Committee. Here, many physicists, chemists, and engineers would meet to research how to make weapons from uranium and plutonium. A lot of time was spent trying to figure out how to get the right kind of uranium for the chain reaction, as natural uranium is a mix of two isotopes, uranium-235 and 238. They only wanted U-235 because U-238 didn't actually undergo the fission reaction they wanted to. It just kind of absorbed the neutron, whereas U-235 was very effective. They essentially had to figure out how to only extract the U-235 from the natural uranium that they wanted because they didn't need the other half. They essentially combined uranium with fluorine to make a sort of gas, which let them extract the isotope they wanted. They also had to figure out how much U-235 was needed to get the critical mass, which is the smallest amount of material needed to sustain a chain reaction. And finally, they needed to know how fast a neutron had to be fired at the uranium to trigger the reaction. In 1942, the project was transferred to the Army Corps of Engineers of America. The work was moved to areas given a code name, the Manhattan District. There were 3 labs located across America, but the most prevalent one was in Los Alamos, New Mexico. Here, Oppenheimer directed the bomb making, where they made a plutonium bomb as well as a uranium bomb. On July 16, 1945, the world saw the first atomic explosion. The event, codenamed Trinity, saw the Gadget, a plutonium bomb, detonate in the desert. The test was a success, but Oppenheimer said watching the test reminded him of a passage from a Hindu scripture.
I remembered the line from the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds." I suppose we all thought that, one way or another.
Oppenheimer knew what would come next. Less than a month later, a uranium bomb, Little Boy, was dropped on Hiroshima, followed by a plutonium bomb, Fat Man, on Nagasaki. About 100,000 were dead from the blast. More followed due to problems with radiation. Looking at the Manhattan Project, we can see it had many important consequences on the world today. We saw the Cold War and the arms race follow it, and it was a big player in this, as the dropping of the bomb was almost a show of force to the Soviets from the USA. This would spark tension for a while. There is good that came out of it. Of course, we have nuclear medicine for medical imaging, diagnosis, and treatment for certain cancers. And of course, there was a huge advance in understanding of nuclear chemistry and physics. And a very important thing that we see now are nuclear energy reactors, which use the same ideas just to make clean energy. And there are pros such as it's carbon free, and the power output's really high. But there are some cons such as uranium not being renewable, and there's high costs. But a common kind of worry is that these reactors can melt down easily and be deadly, which most likely won't happen as these reactors have intense safety protocols nowadays. So they're pretty safe. And also another worry is that what is the smoke coming out of the top? But that's actually just water vapor. So these reactors are actually they're good for the environment, and they're actually effective to use to produce energy efficiently. When looking at the Manhattan Project, it is a complicated topic to make an opinion upon. Many scientific breakthroughs were made with nuclear fission, which has led to nuclear energy plants, which are a great source of clean energy. It also helps certain cancer treatments, which can't be looked over. On the other hand, we see how many lives were lost at the hands of what was researched and created during the Manhattan Project. All we can say is that science and history can be complicated. We can appreciate the research and effort in the Manhattan Project, but we can critique the way its work was used in 1945.